Hello, my name is Michelle. I'll be attending Challenge 2009, and today I'll be talking to you briefly about derivatives. Here we have the function f of x, and a derivative is just the instantaneous rate of change at any point on the graph of f of x. So, to illustrate this, I'm going to draw a secant line on f of x. And if we found the slope of the secant line from here to here, that would give us the average rate of change from this point to this point. So to find the instantaneous rate of change, you would draw a tangent line that passes through the one point that you want to find the rate of change at. And we'll call this point x, and that's where we're going to find our derivative. Okay, so we'll have a point of the secant line, and we'll just say that the distance from this point to this point is h, and we'll call, my bad, overextended. Okay, so we'll call this x plus h. So when you name the points, this would be, the coordinates would be x and f of x, and then here it would be x plus h and f of x plus h. Okay, so to find the slope of the secant line, you would use the old formula, slope equals y2 minus y1 over x2 minus x1. So you plug in your coordinates. Y2 in this case is f of x plus 2, x plus h, my bad, minus f of x over the x coordinate here, x plus h minus x, which would just simplify to h on the bottom. So if you wanted to find the average rate of change on the secant line, you would plug in your coordinates here, and you'd end up with the slope of a secant line. So to find the derivative at this one point, you want to take h and bring it down as close to 0 as possible, so that it's like you're taking the secant line and bringing it all the way in, and you're finding a slope here. So what you do for the derivative, you say the limit as h approaches 0 of f of x plus h minus f of x over h. And this is the definition of derivative. So we're going to go ahead and do an example problem of a function, whatever, okay. We're going to do one of those, and we're going to say like f of x equals x squared. So then to solve for the derivative, you're going to take the limit, as we said before, as h approaches 0 of f of x plus h minus f of x all over h. So in this case, f of x plus h should plug in for x here. So it would be x plus h squared for f of x plus h, and then f of x is equal to x squared. So you put in x squared here, and then put that over h. Okay, so then you're going to FOIL this out. You expand it, and always write limit beside it as h approaches 0. So this would be x squared plus 2hx plus h squared minus x squared over h. Okay, so x squared minus x squared, they cancel out. And then you can cancel out your h's, and you're left with limit as h approaches 0 of 2x plus h. So if h goes to 0, then your answer would be 2x. And that's the derivative of x squared. Okay, so now that we know that the derivative of x squared is 2x, I'm going to write that down because we're going to solve one more problem so I can show you a pattern. One way of writing derivative is just putting a little tick mark here. It's called f prime, which is the same thing as the derivative. So f prime of x is 2x. So now I'm going to solve a similar problem just to show you a pattern of derivatives with exponents. So I'm just going to say f of x, I'm going to call this g of x instead. So I'm going to say g of x equals, let's say, 4x squared. Okay, so in order to find g prime of x, you're going to have to take the limit as h approaches 0. Doing this again, so you would put in x plus h and for x squared, so it would be 4x plus h squared minus g of x, which is 4x squared. And then we'll put that over h. So when you FOIL this out, it's going to be limit as h approaches 0 of 4 times x squared plus 2xh plus h squared minus 4x squared all over h. So then distribute the 4x squared plus 8xh plus 4h squared minus 4x squared all over h. So again, our first and last terms cancel, and then we can take out the h's here. So we're left with limit as h approaches 0 of 8x plus 4h. When h goes to 0, this is 0, so we're left with 8x. So g prime of x is 8x. Okay, so the thing that happens in both of these problems with exponents is that the derivative of any number, dx of x to the n, equals nx to the n minus 1. Because here n was 2, and we did 2 times x, and that came here. 2 minus 1 is 1, so x to the first is x, so that's the derivative. And then here, n was 2, so we did 2 times 4 is 8, and then again, 2 minus 1 is 1, x to the first is x, and that's the derivative. So this applies to all exponential, well, most exponential problems that are set up like this. What's my brief description of derivatives?